3.2 is logarithmic functions. And the big thing with logarithmic functions is that they're really inverses of an exponential function that we're going to write a different way. So here's the biggest thing that you have when we're going through this one. That if you're doing, and they kind of write it a different way when we're talking about these. So if you go back to the exponential functions, if you're doing some number where the base is whatever it is, to a y power equals x, what we were doing last time. Last time, we're going to switch the y in this one because we're going to do the inverse part of it. Here's basically what it is. Now when we talk about logarithmic functions, sometimes they're going to just say it's log for short. So we don't say logarithmic over and over. And on your calculators, you'll see the log button. So that's what we're looking at when we're going through these. When they ask you to, and here's what they have you do. So if you've got some exponential function that you have, and they ask you to rewrite it in log form, the one thing that's going to be that you have is that when you write it in log form, of course, you're going to use the word log. That's here. Everything, now the base, and when you do log form, when you write the base part, the base actually goes down underneath the bottom of it. So the base is there because it'll be the bottom of whatever we're doing. All you have to do with everything else that's back here on this part is just switch these two parts. The x is going to go on the left side of the equal sign, and now the y will go to the right side. So that's the inverse part of it, is that when we're doing inverses way back in chapter 1 and chapter 2, all we did was just switch the x and the y's. This one, and they had you rewrite it and do everything, but for this part of it, all we're going to do is switch the x and the y values and then put the word log in there to make it a log function when we're going through these things. And as you're going through the parts on this one, all they're going to have you do in the very beginning of it is just get you used to taking an equation and rewriting it, and then once we've been able to rewrite these and do a few things with it, they're going to ask you to then turn back around and use some properties, and we'll get the properties here in a minute, to be able to solve some of these problems and kind of work through some parts. Okay, so here's what we're going to do. So some of these examples, they're going to, I think the first thing they're going to ask you to do is they're going to give you an equation that's in log form and ask you to rewrite it back in exponential. So very first thing is we'll do both. We'll go from log to exponential, and we'll go from exponential back to log. And once you're good just rewriting them, then we're going to show you a couple of properties that you can use to then go back and start simplifying and working out some answers here. So you've got the log of 216 base 6 equals y. So when they ask you to rewrite it back in exponential form, that means that you're going to take the same equation you've got, and now you're going to get rid of the log, so it'll be gone. The one thing that stays the same is your base. So if this one's base 6, your base 6 will stay the same here. And then the other two parts that you have here, just switch these two numbers. So it's 6 to the y power equals 216. 6 to the y power equals 216. Okay, so here's another one. And again, just putting some numbers in different places. You got 3 is equal to log of 27 base x. Now, the first couple of problems, it should just be a rewrite. Once we get the rewriting part, show you properties, then we'll actually go back and show you some simplifying on these. Go through it. Okay, so for this one, again, they ask you to rewrite it. The one thing that stays the same is the base. This one, the base is x. So over here, this base will stay the same. And basically, the other two numbers, you're going to switch it, where it's not this way, but if you look at the log property, it looks like it's x to the 27th power, which is really not what it is, but it looks that way. So once you get over here, this 27 that kind of looks like the power is now going to be over here by itself. And this 3 that's by itself is now going to be with the x. Okay, and the last one, this is one of those that we'll kind of let this roll into the next problems that we'll do, just so you kind of see what's going on. But here's a problem where this is one of those problems that you're not, if this was what they gave you on a question to answer, this is a problem that you couldn't use your calculator on the way it's set up. But if you take this thing and rewrite it, for this problem, your base is 9, so that'll stay the same. The other two numbers, you're going to switch it. And this is the kind of problem where a lot of people go, well, if it's 9 squared, can I just say the answer is 81? If they ask you to solve it and simplify it, yes, you would just say the answer is 81. If they ask you just to rewrite it, that's all you have to do, because they're not going to do that. So if they had said to solve it, then go ahead and do x squared, or do the 9 squared, make it 81, and x would be 81. But that's where they're going to in the next few problems, in the next couple of sections, is that if you have a problem that's here that you're not able to solve, then rewrite it in exponential form, and once you do that, the answer should hopefully jump out at you so you can kind of see what's going on. Same thing with this one back here. We could eventually work through this problem a little bit and find out what the answer was and get the answer that we're looking for. But that's the whole thought process, is that if there's something you're not able to do in log form, then you turn around and rewrite it in exponential. If you get an exponential problem that you're not able to solve, then you turn around and write it in log form. So they're just having to go back and forth on these to get through the problems here. Okay, so let's switch gears on this one. Let's go ahead and take these and rewrite it in log form. So for this one, we'll go 2 to the negative 4 equals 1 over 16. Now, and this is one of those, this is one that there's no solving on this one because there is no x. It's just, this is an expression. But again, this one you're just rewriting it, so it's mostly just being able to change it from one form to the other. So when you rewrite it in log form, of course, you use the word log. This one is base 2 because it's 2 to the negative 1/4 power, so that base will stay the same. The other two numbers, you're just going to switch the places. The 1/16 goes over here, and the negative 4 goes over by itself. Mm-hmm. Okay, so you've got 5 to the x equals 27. Yep, throw the word log in there. This one is 5 to the x power, so 5 is your base, so we're good there. And again, these other two numbers, just switch them. The 27 will go over here, and the x goes over there. That and here's one. This is the one where they try to get a little tricky with these. Third root of 8 equals 2. That for that problem, it's not written as an exponential. This one is just a radical form. So before you can do anything on this one, you've got to rewrite it in exponential form. That we've got it in a radical form, which is great, but we don't know. There's not a certain form. I mean, there's a formula, but it's easier just to take it and rewrite it back in exponential. So what you've got to realize for this one is that with the third root of 8, when we're talking about radicals, that this 8 is your base. Anytime whatever the radical number is here, that's like the fraction part, the denominator of a fractional exponent. So this basically would be 8 to the 1/3 power. All right, so when you're rewriting these to exponential form, whatever number they put here, that will always be your denominator here in fraction form. And if they get, now, unless they give you, like, let's say this was 8 to the 4th power, if they put a power in here, that would be your whole number that would go here for the numerator. But most of these, they're not going to have it written that way. So for this one, it's almost like it's understood that's 8 to the 1st power. So whatever you've got on the outside of the radical here, whatever this root is, that root will always be the denominator in the exponent that you're working with. So this problem really is 8 to the 1/3 power equals 2. Now that you've got the radical gone, you've got an exponential form. Now you can actually rewrite it from there. Your base is 8. So that's log with 8 as the base. And then just switch these two numbers. Okay, so that's most everything is going to already be set up. That's one of the weird things that they may throw at you where something's not in exponential form. So with the radical form, just realize that again that number basically means you're going to have a fraction problem in the exponent, and this will always be your denominator when you rewrite it there. So that's basically the same thing as not the A part. We're going back up here. I think it's like the other example was back up here. We had a fraction. Did we know? No, that was the first one with a fraction. Okay. Okay, so once you've gone back and forth and done some rewriting, going from log to exponential, exponential back to log, the next thing they're going to have for you to look at is they're going to give you some just different properties that you get with these. Okay, and the first time I saw these, they give you the properties, but sometimes if you don't break them down a little bit, what their properties are actually saying will kind of fly past you a little bit. So this is, when I first do this, when I'm going to give us a property, but I'm going to put a question mark there instead of giving the answer, because sometimes if you give the answer, you don't understand what they're asking. So let's kind of, let me back up and show you what we're looking at. So here's what they're going to do. They're going to say if you've got the log of any base, doesn't matter what it is, and you've got a 1 that's here, we're going to figure out what that answer would be. Now, and this is one of those things that when they give you the log property, if you understand what it is in exponential form, it kind of gives you the answer. So when you see this problem, what we're doing really is we're going to think exponential. So if we take this problem that we have here and rewrite it in exponential form, this would be b to the what power equals 1. So what did we say last time? That if you do anything to what power, it's going to equal 1? I mean 0, right? So anything to the 0 power would equal 1. So if this question mark is here, basically here's what it is. If you have log of 1, doesn't matter what the base is, this answer will always be 0. And that's the very first property they give to you, is that if you have log of 1, it will always equal 0. And it doesn't matter what that base is, whether it's 2 or 43 or 1/15 or whatever, that anytime you see log of 1, it's automatically going to be that if you simplify that, it's going to be 0. So this is, and again, if you kind of think about it, rewriting it, how it works out there, it kind of helps you understand why that log of 1 is 0. Because if you rewrite an exponential form, it has to be 0 for the base, or for the exponent that's there. All right, property number 2. Okay, for property number 2, here's what you're looking at. If these two numbers are the same, if this, whatever your base is, if this number that's here is the exact same thing, there's a shortcut to it when you're simplifying this part. And again, if you think about rewriting it here, it's b to the what power equals b. Just the first, right? So for these two things to match up, this would have to be b to the first. So for this answer, anytime that these two things are the same, it's always going to equal just 1. Okay, 2 more. And the last 2 are the same, just written a little different way when we look at them. And number 3 is actually the same as number 2, just a little bit extra that's in it here. Okay, and again, before we get to the actual answer, again, here's what we're looking at. We've got this base and this base the same. So this part of the base will stay the same. And then we're going to switch these two numbers. So b to what power make it equal b to the x? What's an equation, right? So these two things would have to be the same. So that means that would have to be an x here. And it's basically that same thing, that if these two things are the same, for property 2, this was an understood 1 power that was here. In this case now, it's basically that that's an x to the power. So if these two things are the same, whatever exponent here, that's going to be the answer that we're looking for. So if you have log of b, and it's b to the x, it's going to equal x. All right, and then the fourth common log property that we're looking at is same thing, but again, just a little twist on this one. And I'm just going to get, and this one we'll kind of throw it out here because it's a little bit different look to it. This time they've got a base that's, it's almost like it's a mix of exponential and log together. But here's the big thing. These two numbers are the same. And if those two numbers are the same, it's basically the same thing like this one where these two numbers are the same. So if these are the same or if these are the same, then the answer is just going to wind up being x. So it's just the same thing as this one, just written a little bit of a different way. Okay, so 1 and 2 are the big ones. Number 3 is basically a little spin-off of number 2, and then number 4 is just a rewriting of number 3. So there's 2 big ones, and the other 2 kind of just little tweaks, little adjustments from those. Okay, now once they've got those properties, then what they're going to do is they're going to ask you, give you some situations where, all right, here's a number that we have. We're going to ask you to take this problem and rewrite it. Oh, and by the way, if you rewrite it, and you can simplify it, using one of these properties, go ahead and simplify it a little bit. So they're going to have you rewrite it, but then go one more step to see, could you answer this? And again, without a calculator, just saying, can you use one of these 4 properties to then take this problem we've got and simplify it? So 3.2 is really everything without a calculator. 3.3, we'll turn around and show you how to use a calculator so that when those things show up, that everything will make your life a little bit easier when you go through it. Okay, so for these, this is where they'll say, here's an expression, tell me what it is. And in my mind, when we're looking through these and they tell you to evaluate, or they tell you to tell me an answer, when I see a problem like this, I was always thrown off because I'm like, where's the equation? Where's the equal part of this one? Because I'm trying to find out what the answer is. So if they give you one like this, again, here's kind of what you can think. If they don't give you an equation on it, you can just take this thing and kind of say, all right, well, here's what I'm thinking then. This is log of 1 base 4 equals x. If it helps you kind of think about it that way. Key thing on this one, though, is this log 1. And as soon as you see log 1, again, doesn't matter what the base is, that means this x has to be 0. Because again, if you were to take that problem and rewrite it, it would be 4 to the x power equals 1. And again, if it's 4 to the x power, anything to the 0 power has to be 1, so that means that x would have to be 0. So we're doing log of 5 to the 7th base 5. And again, just in my mind, when I'm seeing this problem, I'm taking this and rewriting it a little bit. So I'm thinking that this is, again, it's log of 5 to the 7th base 5, but to me it's really equals x, because I'm trying to, if they tell you to evaluate, you're looking for an answer. So you're trying to figure out what that is. Key thing on that one is, again, is that these two numbers are the same here and here. And if those two numbers are the same, whatever you've got here, that's going to be the answer that you're looking for. So if they ask you for this one, the answer would just be 7. And again, they tell you to evaluate it. Technically, there's not going to be an x equals. It's just going to be 7. So, technically on these, you won't have an x equal. It'll just be a 0. So answers here. But again, if you're thinking about it, really, again, because we're just kind of thinking through the process, that really it's x equals 0. Same thing back here on the previous problem. If they ask you to evaluate this, it should have just been 0, and that was their answer. Okay, here's one where it gets going back to kind of like one of the previous problems from earlier. It's the log of the square root of 7 with 7 as your base. And if you remember with square roots, that if you're doing the square root of 7 or square root of anything, that if you're doing square root, technically that's the second root. So when they give you this problem, that really means this is the square root of 7. So you got your square there. So if you were to take this thing and rewrite it, that really means this is log of 7 as our base. This is really 7 to the 1/2 power. So then that problem really is the same thing as the previous problem here, where these two numbers are the same. So if you simplify this one, then 1/2 just becomes your answer. All right, let's do one more of those. And the D part kind of spins off the question that's here that for this one. This is base 7. This was also base 7. So if the bases are the same, this number that's here is going to be the answer that you're looking for. So when they ask you to evaluate it, your answer is just 23. So as you're working through, and that's the big thing they're trying to get you to see, is that if you can get the problems rewritten so the bases are the same, if you got the base here and this is another base, just a different kind of base, if those are the same though, they get to cancel each other out in a sense, and yeah, whatever number you got, that's what you're looking for. Okay, and then the last two things that you have to work through in section 2. First one is, I'll just kind of say it this way. If an expression, or if a log expression, does not have a base, then it's understood to be base 10. Because sometimes you'll see a problem and they'll ask you just to rewrite it or to solve it or to simplify it or whatever it is that they ask you to do. And they'll just give you one like this. So this will be the problem, and they'll tell you just to evaluate, kind of like the last previous problems that we had there. So if you have log of 10 squared, well, and some people go, well, there's not a base here. Okay. Again, that's where, again, you just got to kind of think or just rewrite it to know that this is going to be log of 10 squared. But you just have to know that if there's not a base there, then that's understood that's base 10. So now you've got your same bases here and here. The answer is just 2. So that's it. So anytime they leave the base off, just know it's base 10. Then you're good to go. Okay, and then the last thing. And this is where, again, they'll kind of talk about this a little bit more in section 3, which we'll get to here in just a few minutes. Is they're going to talk about natural logs. And this is not the kind of logs that you go find in the forest somewhere that somebody's cut down for you. Different kind of logs. When they talk about the natural logs, this is how we talked about, back in section 1, we talked about when you're doing the financial stuff and you've got the E that pops up when we're talking about the numbers. This is base E. And if you check E is one of those numbers that's 2.718. And then it just has this runoff number that it goes through. But basically it's 2.7. If you need one decimal place answer, it's pretty much that. You could take it out a few more decimal places. But it's basically 2.7. 2.718, 2818, 2845, 9045. It just keeps going and going and going and going and going and going and going. But 3 decimal places of 2.718. That's the approximate part, yeah. Okay, now, and here's the big thing. When you're going through these problems, you will not see log of E as your base. You will not see log of X with base E. You will not see that. And instead of seeing this, instead of doing log with E as the base, they say, all right, well, since this is one of those numbers that kind of just naturally happens, we're going to put a little shortcut in here. They're just going to put ln, and then they'll put the X here. So anytime you see ln, that's the same thing as saying it's the log of base E, but they just say it's a shortcut, it's ln. Now, and most people go, why is it not NL? Because it's natural log. Well, because it's French. So they said log naturel. That's why it's ln, because they did it for short. Okay, so what they're going to do, now the same properties kind of hold on this thing. those same 4 properties that we had with just the word log, it's going to be the same thing, but now they're going to use the ln part of it. So before we had the log of 1, didn't matter what the base was, it was going to equal 0. Well, if you put it in natural log form, it's the same property, but now instead of being log of base b, or whatever the base is going to be, it's just going to be ln of 1. So anytime you see the ln of 1, then that's automatic answer of the answer is 0. And if you want to check it on your calculator, you could you should have an ln button on there. If you put in ln 1, hit enter, it should give you 0. But it's that same thing of here that we're just taking this thing and rewriting it, so that's all right. Anytime you see the word log here, you can basically take that out and put ln in its place. And that's what we're going to do for the properties. So the second property we had was where we took the log of b, where the base was b. And again, if these two bases are the same, it's just going to be whatever the exponent is that's here. Well, there's not an exponent, so it's understood 1. So when we're rewriting this one in log form, it's going to be the ln of, well, we just said ln was always going to be base e. So this one, they're going to put an e here. So if you see the ln of e, they just kind of cancel each other out. That's going to be a 1. And sometimes people kind of they're like, well, how does that work? But again, you've got to think that if you're doing this one, that means we're doing log of e with e as the base. And again, they don't write the ln, they don't write it that way, but you just have to think that anytime you do ln, really it's the log of e as the base. So there's your two numbers, it's the same. Okay, and with this one, the only difference was that now we put an exponent up here. And again, these two things would cancel to give you just x. And in an ln expression, it's the exact same thing, but you're just going to put an x up here in the exponent. So that will give you x. Okay, and the only difference between 3 and 4, that instead of the two bases being together, just had the two bases kind of separated, so it was like that. I'm going to put that b in there. That's a little bit confusing. Hang on. Wasn't reading very well. There we go. And that's what's hard to tell. That was the base. So this one, it's log of x, where there's their base here. So this one, the bases are kind of spread out, but the same. Still give you the x. In the ln form, it's going to be e to the ln of x. And again, as soon as you see ln, that basically means you've got the base e, so these two things are the same. So that'll just cancel out, and then it'll just make it x. Okay, and then the last thing they'll throw at you should be that they're going to have you evaluate, do some problems with ln instead of log. So we'll have you evaluate a couple of problems here. So let's say, all right, here's one. Evaluate ln of e to the 7th. If you look, that's like number 3 back here, that you got ln of e to the x. If they ask you to simplify it, it's just this exponent, so same thing. The answer is just 7. That basically, if you want to kind of visually think about it, the ln and e always cancel each other out. Whether the ln is first or the ln is second, anytime you get ln and e, they cancel each other out. Now, they have to touch each other. That's the one thing with this one, if you look at it that way. They have to be together. You can't have an e and then a 4 and then an ln of x over here. They have to kind of be touching each other to cancel each other out. That's kind of the big thing you want to get when we're looking at 3 and 4 there. All right, so for this one, let's do e to the ln of 5x to the 3rd power. A little more stuff to it. But again, the E and ln knock each other out. So as long as you've got the E and ln together, they just cancel each other out. That's gone. The answer would be 5x to the third. Okay, and then one more. Let's say they give you ln of e. And again, if you kind of stick with the whole ln and e canceling each other out, if you kind of look back at the a part, this was e to the 7th gave you this exponent, so technically that's e to the first power, even though it's not there. So for that answer, the answer, if they ask you to evaluate, the answer would just be 1.